Hello and welcome to Tribe Topper. I'm Sonal Gupta, and this channel is about increasing your understanding of physics. To clear your concepts, subscribe to our channel and click the bell icon for latest updated videos. In this video session, you are going to learn about resolution. So, what do we mean by resolution? We all know we are always interested to buy the cameras. Different phones have different cameras which have better resolution. So, what resolution means? It's actually the ability of an imaging system to be able to produce two separate, distinguishable images of two separate objects. That means if I have two objects here, then my camera or the human eye as an imaging system should be able to see them as two separate and distinguishable separate objects. Quite distinguishable, right? Now, this resolution of the image that is captured either by the human eye or the camera, that can be resolved or not. It will depend on number one, the wavelength of the light that is coming from these objects. Number two, how close they are to each other. Because if they're too close, it's sometimes almost impossible if they are like overlapping each other or something. It's almost impossible to produce two separate and distinguishable images. And thirdly, it would depend on how far they are from the observer. And based on these criterion, Rayleigh, he gave a criterion for resolution of images known as Rayleigh criterion. So according to this Rayleigh criterion, the two sources are resolved if the principal maximum from one diffraction pattern is no closer than the first minimum of the other pattern. So that means that I have this source. If there is a principal maximum, this is the principal maximum of one source. How far is it or how close it is to the second one? It is closer by what distance? This is the gap between the principal maximum and the first minimum of the next one. So this is the principal maximum of one. It is lying at a distance equal to the distance of the first minimum of the second pattern, right? So if there is this much gap, then we would say that these two will be fully resolved images, right? As you can see here, it's written images are fully resolved because in this case, the principal maximum from the one pattern is how far from the other one? It is at least far equal to the first distance of the first minimum from the principal maximum. If you look at this picture, we would say the images are just resolved. Like you can make out that there are two objects, but they are not like fully resolved. Because if you see here, the principal maximum of one is going closer to the principal maximum of the other. So they're almost coinciding, right? They are overlapping each other. So this distance or this pattern is not almost, we would say it's almost not satisfying the Rayleigh criterion. So these images are said to be just resolved. And if we talk of this figure, these are absolutely unresolved images because they are almost the two principal maxima of the two sources, right? There are two principal maxima from the two sources, they are almost coinciding one on the top of the other. So in this case, the Rayleigh criterion is absolutely not satisfied, and so the images are unresolved. So if just to see again, this is the first case where we had a clear cut, a resolved image, a fully resolved image of two principal maxima are separated by a minimum distance which is required there to be, right? In the second one, they are overlapping each other, but we would say the images are just resolved because we can make out there are two. But in the third case, the two principal maxima are coinciding almost. So there, these images won't be resolved. And there is an equation for the resolution angle, and that is that the angle of resolution theta is equal to 1.22 times lambda upon A. You don't need to understand how we got this equation. You just need to know that the angle of resolution is given by 1.22 times lambda upon A, where lambda is the wavelength of the light and A is the circular aperture, like for the lens or your human eye or the camera or the mirror through which you're checking the image. That circular aperture is A. So that's all for this video session. In the next video session, you are going to learn about the Doppler's effect for sound waves. Thank you.